Okay, thanks everybody for staying here and not going to eat to the next room. And, and thanks for the organizers for inviting me. So today I'm going to talk about Rootstock. Rootstock is the code-name of the smart contract platform we are developing at RSK Labs, which is the company that we founded the last year. So first of all, I'm Sergio Lerner. I'm from Argentina. Is there anyone else here from Latin America or South America? I saw Nicolas there. Okay, so there's we need more decentralization, but we have some Latin Americans. So I'm a computer security researcher, and I'm also an entrepreneur. My first company was a high-tech medical company in neurophysiology, but when I discovered Bitcoin, then I completely switched, and I started creating Bitcoin companies. And but from the very beginning, I started working with smart contracts, and so this is the culmination of a lot of years of work. So I'm going to start from some simple concepts about smart contracts. I hope I don't bother. Okay, then I will start with more complex things. So when I had to explain my mother what I was doing with this, I found that I had no explanation for her. So there's two ways of understanding a smart contract. One way is that a smart contract is a way to attach rules, to attach a program to money in a payment network. So for example, I can send you some money and at the same time restrict that you can only use that money in the university campus, for example. And the other way to understand a smart contract is the other way around, where you have already a program and you say, okay, I'll give this program control of money. Then a classical example is you have a distributed DNS system where now you enable this system to accept payments to register new domains. And what's the relation between Bitcoin and smart contracts? Well, Bitcoin has a very limited implementation of smart contracts. And one of the classical examples of this is the multi-signature wallet that most of us use. It's based on this scripting system and a special opcode to validate multi-signature. But taking the case of a Bitcoin wallet, there are things that we cannot do. For example, we cannot apply limits in the amount of daily withdrawals. And this is because we require some persistent memory to store the partial amount of money we are spending, and also because we don't have reflection. We don't have the possibility to inspect the block timestamp or to inspect the transaction amount. Also, one of the things one would like to do with a wallet is to have some whitelist payment addresses or blacklist payment addresses. And we cannot do this with Bitcoin right now because we cannot inspect the destination address of a transaction. So why is that Satoshi chose to implement this restricted non-Turing complete fourth language in Bitcoin? Is that there is a reason for that, and that reason is to allow transactions to be replayed when there is a huge reorganization of the blockchain. Basically, in that case, you can just take the transactions from one of the branches and just put them into the other branches, and then everything keeps working. Well, at the time Satoshi thought about this, I think it was a very good design goal, but at this time, we don't see much huge reorganizations in the blockchain. So we can start to think, what if we could include introspection into transactions so they can relate to the block, read the block timestamp, for example. So these are the restrictions of the Bitcoin scripting system. It's not Turing complete, we don't have goto, we don't have recursion. The available resource, no persistent memory, and there is almost no context inspection, and most of the interesting opcodes we can find in Bitcoin are disabled. So we want to extend this. We want to give Bitcoin the power of smart contracts. So how do we implement smart contracts in a blockchain? Well, there are, as far as I know, only 3 possibilities to do this. One is using an off-chain system. Basically, we have a set of privileged nodes that will execute the smart contracts. They will produce a result, and for a certain consensus system like voting, we will pick the correct result. And this was tried, this is called Oracle-based smart contracts. This was tried by Ripple in the in the Codius system, which was later deprecated. And also, this was an idea of Nick Szabo when he proposed a tamper-proof open source hardware, but that would be auditable for everyone, that we could attest that it was working correctly, but no one would be able to tamper with. Obviously, this is terribly difficult to do. The other interesting way of doing smart contracts is to have a hybrid on-chain verification and off-chain execution. And you can actually do this with a very fancy and interesting cryptographic construction that is called SNARK. This is very, very promising, but it has some drawbacks that, for example, it requires a trusted setup, and the current implementations are fairly untested. So this could be problematic for a platform right now. So the third way is the way that Rootstock does and Ethereum does, is having deterministic replicated execution, which basically means that every node executes every instruction of every smart contract. And this might look, seems too much for a simple node, but soon you realize that once you have this setup, then you can emulate both smart contract-based execution and SNARK-based execution with the minimum possible cost. So basically, this solution allows you to grow into any other possible smart contract solution. So the history of practically implemented smart contract platform begins, again, as far as I know, with Quickscoin, which was deterministic replicated engine, which was created only for gaming and gambling. At that time, I was working on peer-to-peer poker playing in my thesis, and so I implemented a prototype which is quite similar to what Ethereum is today, which allow you to play poker, peer-to-peer poker, using a cryptocurrency and a smart contract platform. Obviously, I was terribly blind to see the enormous financial applications of this technology. I was just focused on poker. And the following year, Ethereum came, Codius was developed, and also the last year, we had Counterparty, which implemented an EVM-compatible virtual machine, and we presented Rootstock. So what is a smart contract for Rootstock? Well, a smart contract is basically a program, an immutable program, that is given persistent memory, and this memory is protected from access from any other contracts, and also has a digital safe deposit box where you can deposit other crypto assets like currency or anything. And it basically can receive deposits and can create payments and can receive messages and produce messages to interact with other smart contracts, to interact with other programs within the blockchain. So what is the distributed application? Sometimes people talk about this. So a distributed application, or dApp, is a collection of smart contracts that work together with the external world application that interact with them. For example, taking again the example as a wallet, we could create a protected wallet that stores BTC and US dollars and allows the owner to pay $1,000 per day, either in BTC or USD. But to do that, these smart contracts, to pay more each day, it would send us an SMS to another person, the wife, the husband, to authorize more spending. And at the same time, it has to see what's the value of the Bitcoin in each moment to be spendings. So basically, it has to interact to two other smart contracts that probably are created by third parties. So basically, the design would include three smart contracts, each one interacting with each other, and each one at the same time interacting with outside world application, which contains the graphic interface, gateways to other systems, etc., etc. So why we choose Bitcoin and why we didn't just go and create yet another new speculative token? Well, it's clear that currently Bitcoin is the most secure decentralized cryptocurrency. And with the advent of the two-way peg, which I will talk about this later, we can do almost anything using the Bitcoin cryptocurrency. We can extend Bitcoin to do almost anything other blockchains can do. Also, it has the most real-world use cases. And it has a large head start and network effect. And mostly, and the most important, we've been part of this community for more than 4 years, and we love it. Even if there is argue all the time, we feel part of it. It's okay. The team. These are the 6 founders of the team, and we also have more programmers now. And we set up ourselves some goals back in November last year. Basically, we want this to be a smart contract layer for Bitcoin. We want to be democratic. We want to increase the number of use cases for Bitcoin. We want to enable financial institutions to be able to comply with their regulation and develop their use cases over Rootstock. We want to incentivize the Bitcoin community and the Ethereum community to test our platform, to work with our platform. And most important, we want high incentives for Bitcoin miners because we want them to join. They are the ones that are bringing security to the Bitcoin network. We cannot forget that. And we want them to be 100% mining on Rootstock. And we've managed to do this, I think. And trying to kind of solve, if that is correct word, the governance problem in Bitcoin. We are trying to bring all the actors, we are trying to test a different governance model where we are trying to bring all actors in the community to form a committee and try to design which will be the changes in the standard. Of course, we want to have low transaction fees, high transaction volume, and we want to scale a little bit more than Bitcoin. We want to scale to 100 transactions per second without problem, to 500 transactions per second without any problem. And obviously, this is a trade-off with decentralization. This is not free, but I think that we already have a decentralized network that is Bitcoin, so we want to be also more scalable. So these are the incentives to the Bitcoin ecosystem we are setting for the governance of the platform. So there is nothing really new here. There is a federation, which I will talk more about this later. Essentially, the 2 interesting protocols here we are using is for allowing Bitcoin users to vote, we are using a classical proof of stake. And this is something we are trying, something new. We are going to try to reward, we are going to try to give votes to full nodes. Here it says Bitcoin full node owners, but they will become Rootstock full node owners. And through cryptographic construction is called proof of unique blockchain storage, where we can actually on-chain test if these nodes are holding a unique copy of the full blockchain. So what's the technology? What's new in Rootstock? We've come up with. So first, of course, we have the smart contracts, and we are doing this as a VM that is compatible with Ethereum. So we've seen a lot of companies. Each day we have a call with a company that say we want to develop in Rootstock, and we tell them, okay, start working on Ethereum, and then if you want, you can switch. And that's important for us because we want to see a standard. We don't want to have a lot of different platforms for smart contracts, and I think Rootstock can implement that standard for Bitcoin. Also, we have the two-way peg, which allows the Rootstock platform to use Bitcoin as the native currency. And because to implement a full automatic two-way peg, we need some new opcodes on the Bitcoin side. We need some new modifications to Bitcoin. We will start with something simple. more simple, that is an hybrid that has a federation and a sidechain. So we have a federation that will have custody of Bitcoin funds and a sidechain on the Rootstock side until we have the automatic two-way peg working on the Bitcoin side. But that's our ultimate goal. Also, we are doing merge mining, which means that Bitcoin miners will be able to mine the Rootstock platform with the same hashing power, with the same machines. They are mining now Bitcoin with no loss on profit in the Bitcoin side. We are making sure that when they do merge mining with Rootstock, they don't lose a single Bitcoin by doing so. And we have the federation, and currently the federation has 3 roles. At the beginning, it will protect the network using checkpoints, which will be distributed by the network. So if a node wants to know if it's being Sybil attacked, it can use the federation checkpoints as a second protection to be sure that it's well connected to the Rootstock network. And it also, we are preparing a failback system where if the merge mining for any reason goes below, can take charge Byzantine fault tolerant consensus system and take the activity of mining on their shoulders. I think this will never happen, but we want to make sure that the platform is going to keep running if we lose the miner's faith. And the Rootstock network, we are having very interesting technical improvements in terms of low latency, for example. So what is different in the Rootstock virtual machine? Well, in the first release, it's actually interpreted VM compatible with the Ethereum VM. But in the next release, in the works, we are doing a dynamic retarget of Ethereum opcodes into a Java-like bytecode. So we'll be able to use standard programming languages like Java to develop distributed applications, and we will test this soon. And also, we will have a just-in-time compiler for this. And regarding the interface with higher-level applications, higher-level applications in Ethereum use a standard that is called Web3, and this standard is pretty solid, so we are implementing the full standard of Web3. So if you write an application in JavaScript that uses Web3, you just switch the network and you will be able to run that on Rootstock. Regarding the two-way peg, I would like to try to state what the problem is. So we have 2 blockchains, which one is the main blockchain and the other is the secondary blockchain. And you want to move Bitcoins from one blockchain to the other. And the problem is that that is not possible. So basically, you have to lock the Bitcoins in or destroy the Bitcoins in the Bitcoin blockchain and then create the same amount of Bitcoins in the secondary chain. After some time, you have to lock those Bitcoin back and unlock Bitcoins in the Bitcoin blockchain. And you need some protocol that enforce that the Bitcoins are never unlocked in blockchains at the same time. And there are at least 3 ways to do this. One is using a federation, which will be the simplest way, using a multi-signature, where, of course, you want to have renowned parties taking part of the federation. The other one is using a sidechain, which is a concept Blockstream has developed, which requires 2 new opcodes on the Bitcoin side. And this is kind of problematic because these opcodes allow you to interpret other blockchains which use the same transaction format as Bitcoin, so it's kind of limited. And the third one, which is pretty convincing for a merge mining blockchain, is called Drive Chain and was proposed by Paul Stork from Truthcoin, which requires a single new opcode, and it's very straightforward to implement. So I think we will in the future decide, depending on what the Bitcoin community wants, to use a sidechain or a drive chain instead of a federation. You can also mix two of these solutions during a period of time, like having a federation that has to approve a transaction and at the same time having the drive chain mechanism. So you can have both groups validating. So I'm going to skip the part about how sidechains work and drive chains work. Basically, I would say that a drive chain is a method for miners to vote on which is the transaction that will unlock the Bitcoins. And if the miner engagement in Rootstock is very high, then the same group of miners will have the power to decide what to do, how to unlock the Bitcoins. And you have the same security level as in a sidechain. So what do we have now? What we have implemented? Well, we are using a hybrid federated sidechain solution where we don't need new opcodes on the Bitcoin side, and Bitcoins are locked just being transferred to a script that is a federation, a Bitcoin address of the federation. But on the Rootstock side, we have a full SPV node running in a contract in the Rootstock side. And that SPV node is synced to the Bitcoin network by means of external messages. This SPV node that we call the bridge provides the locking and unlocking services for Rootstock users and Rootstock smart contracts. And also, it's important to know that the bridge takes a long time to transfer the Bitcoins into root coins, which are the Bitcoins that live in Rootstock, and back. And this is intentional because we must protect the network from long reorganizations. And if that occurs, it could create Bitcoins that live in both blockchains. So to be able to transact, to turn Bitcoins into root coins and back very quickly, we are partnering with exchanges to provide the liquidity just to trade one Bitcoin for one root coin immediately or in few time. So how the federation works? Well, the federation is running a special software we call the Fed node that runs a Bitcoin node and a Rootstock node at the same time. And the Fed node listens to the events created by the bridge, and it just has to obey what the bridge says. They have no manual intervention. So the bridge says, okay, this is the transaction you have to sign, and then the Fed nodes automatically go and transmit to the bridge the signature, and then the bridge assembles all the signatures, creates the transaction, and announces, hey, this is the transaction that you have to broadcast on the Bitcoin side. So there is no intervention of the Fed nodes into the decision of which outputs to spend or anything else. So this is how it works. Basically, we have this Bitcoin J. It's actually Bitcoin J code running an SPV node in the matrix, because this Bitcoin J node thinks he's connected with the network, but he's not. He's living in a virtual world in a smart contract. And to lock Bitcoins, nodes can send the headers to this bridge contract, and they also can send the transactions that lock the Bitcoins with an SPV proof, so the bridge contract can receive those Bitcoins and release root coins. So the bridge actually has a Bitcoin wallet, a copy of the Bitcoin blockchain in SPV mode, or the list of headers, and a Rootstock account to be able to unlock the Rootstocks, the root coins. So this Rootstock account initially has the 21 millions of Bitcoins locked in an account. And here's another diagram about how the federation works. There are several Fed nodes running, connected to both networks. And this is the upper part is a failback system, which will eventually can take control of the mining operation if the mining engagement goes below a threshold. And this is all automatic, and it can be fooled. So what is needed to implement the target, the two-way peg? Well, we need new opcodes on the Bitcoin side, either to do a drive chain or a side chain. And this can be done using a soft fork or a hard fork. And we are sponsoring a project we call Bits2 that will bring these opcodes to the Bitcoin community, to consider which is the right path to go. So we want the Bitcoin community, of course, to decide. I think that soon we'll have a lot of debate about how to extend Bitcoin. Probably Blockstream will be very interested in taking part of this project. And the other thing I talk about is the checkpoints protection that the Federation provides. And basically, it's an alert system for nodes to be able to detect if they are civilly attacked. The other thing that Rootstock uses is merge mining. And basically, we have a target 10 seconds block interval, and we have tested and simulated this, and it works pretty well. We have no loss in pool efficiency for Bitcoin mining, and that's very important to us. And we are playing with automatic feed of Bitcoin headers to the bridge contract using the SPB proof, that the proof of work that Rootstock uses. And this diagram shows how a proof of work of Rootstock, the parts of a proof of work of Rootstock, it contains the SHA-2056 mid-state of the Coinbase transaction, so you can actually embed the tag and the hash of the Rootstock blockchain, the Rootstock header, in the last part of the Coinbase transaction, and you don't have to transmit the full blockchain, the full Coinbase transaction. You just transmit the mid-state, the tail of the Coinbase transaction, which contains a hash, and that hash maps to the Rootstock header. And you also transmit, of course, the different nodes in the Merkle tree to be able to map that into the Bitcoin header. One of the other things we've been working is the integration with the most known and used mining pool softwares, because we want the miners to be able to run our node and do merge mining. So actually we've created plugins for D3 implementation, Coinune Serve, CK Pool, and Alloy Pool. So when we launch the platform, these plugins will be ready for you just to merge, if you have some private code, to merge with your private code, or just use the public code. So what's new in terms of network? Well, the network, we aim the network to be low latency and high volume, and we've tested without promise to have 300 transactions per second, the 10 seconds block interval, and to allow this to happen, we've implemented mostly known tricks about how the network can operate. Basically, we have two-stage block propagation. We first propagate the header of the blocks in a kind of a flute field algorithm where the header propagates as fast as possible, so every miner can start working on that header, and then the block information comes. And miners implement a timeout to be able to switch to what they were previously doing if the header does not come with the block information. Also, we have some interesting here is we have some local route optimizations in each node. Some local decisions can be taken to have to embed into the gossip network a graph that is more friendly to block propagation. So you can actually find the minimum path or near minimum path between miners using the network itself, and you don't have to have a different block relay, low latency block relay network that is centralized in the case of Bitcoin. We are implementing the Ghost protocol in the same way as Ethereum, and we are implementing the Decor protocol, which I designed for reward sharing in case of competing blocks. And using that algorithm, selfish mining problem completely disappears. And also, by using Decor, the competition for latency goes away, so we can have much higher block rates. Okay, this is an explanation how Decor and Ghost work together. Basically, this is a case where we have three competing blocks. This is block W, block X, and block Q, which have the same height. And in following blocks, the miners can include these uncles, these headers, and they receive a reward for including these headers. And after some maturity period has passed, the block reward of block X is divided almost evenly between all the competing miners. There is some extra reward that the miners who include uncles get, and there is a punishment fee for having uncles, which pushes the network to optimization instead of pushing the network to a state where everyone create uncles. And in the future, this probably will come in the first hard fork. We are doing the classical optimization in blockchain sharding, like probabilistic verification and fraud proofs. We will have user programmable signature schemes. Apart from AC DSA, we will be implementing short signatures. The important thing here is that we will give complete algorithm agility. So you will be able to create an account and use whatever signature algorithm you can think of. And also we will be including a special proof of stake voting key so users can use that key to vote with their stake, but prevent to have two different key lifetimes. One for the monetary assets to protect the assets, and the other just for voting, which is something very important for proof of stake. This is a comparison between the three Ethereum VM implementations. We've tried to improve every feature of the network. And talking about distributed applications and trying to move from the technical part to more the community part. And this has for those who are not in smart contracts, there are many use cases for smart contracts, and there are plenty of companies that are working on those use cases now. These are just a few examples of smart contracts applications that we've been contacted, companies doing this, like micropayment. Oh, this is very interesting. The whole Lightning Network can be implemented in about 100 lines of smart contract code. So the Lightning Network will be much more efficient and much more simple over Rootstock. We have peer-to-peer distributed exchanges, decentralized escrow services. Of course, we can create crypto assets, supply chain traceability that somebody has talked about this, fair internet gaming and gambling. The full poker client will be able to run on Rootstock, crowdfunding, voting, prediction markets. These are all applications that have been widely discussed in the community. So how is the project going now? What progress we've made? Well, in November, we published the white paper. In December, we started coding and designing and coding. In January, we founded a company to provide, to have the resources to bring this to practice. And we received seed funding from very strategic partners like Concilium, Digital Currency Group. I don't know if Melton is here. Thanks. And we've received more than 1 million in funding, so we are pretty sure we will get to our goals. And in February, we hired 6 senior developers, 3 which are internal to Rootstock and 3 which are being outsourcing. And we are developing, of course, industry partnership with the miners and these companies that want to work with us. And we are in March, we are perfectly on schedule. And how we achieve this, how we achieve to develop Rootstock in such a short time? Well, we took the improvements I had created in QuicksCoin and NimbleCoin, But we took the code that was already written. We don't want to rewrite everything from scratch. So we took Ethereum J, which is a fantastic implementation of a Ethereum node, and we took Bitcoin J, which also is a fantastic SPV implementation, or the only one implementation of an SPV node, and we brought that code into Rootstock. So this is our roadmap for this year. In April, we are doing our first private testnet for a few partners of us. In July, we'll plan to deploy our first public testnet. In August, we will establish the federation with all the members in the first federation. In September, we want to have the platform launched. And in December, well, we are going to test the release 2 of the platform. In January, we will have the governance body ready to be able to take decisions on how the protocol should be improved in the more democratic way. And next year, we will have the first hard fork for the release 2. Okay, as a summary, Rootstock is the culmination of 4 years of blockchain technology improvements. Not ours, but from all the community. So this is the benefit of being second. And we want the Bitcoin miners to participate in this revolution, smart contract revolution. And we've got excellent support from them. So that's very important for us. Also, we managed to get Ethereum applications running on our platform without problem. And most importantly, and this is important for me that I come from the third world, we are working with companies in the third world to develop applications for financial inclusion of the unbanked. And right now they are developing their use cases or their pilot use cases over Rootstock. And if you want to read more about Rootstock, the white paper is available in our website. Thank you very much. If you have any questions, if there is time, please.